Hi everyone, my name is Jennifer Jenia Anak Ingkamat and I'm from J4EM1103A. I'm conducting an experiment which is experiment 5, observation on the microstructure of cast iron. So this is the report of the experiment.
The objectives of this experiment: to observe microstructures of cast iron under optical microscope and to identify the classification of cast iron according to the characteristic of the microstructures obtained. Apparatus: metallurgy microscope. Procedure: first, switch on the computer. Second, double-click on the iSolution Light x64 icon, click on the image capture icon on the left side of the interface and choose Live Measure icon at the right side of the interface. Third, switch on the microscope. Put the sample on the workstation and place the sample under the magnification lens. Bring up the workstation by adjusting the cross focus slowly until the sample goes up to the magnification lens. Adjust the optical lens accordingly to both of your eyes until the image that you see is quite clear. Bring down the workstation by adjusting the cross focus slowly until the image of the sample appears on the computer interface. Image more clearly, you can adjust the focus by using the fine focus adjuster. You can adjust the magnification lens for zoom in the image on the sample surface by rotating the magnification lens. Continue observation on every sample that you have been given. And switch off the microscope and computer after finish.
The carbon percentage of steel is between 0.2% and 2.1%, while cast iron has a carbon percentage of 3.0% to 3.7%. Cast iron is harder and stronger but is not as tough as steel. Steel is tougher but is not as hard and strong as cast iron. Steel has ductile and malleable properties and its melting point is higher than cast iron. Gray iron is weak and brittle in tension because the tips of the graphite flakes act as points of stress concentration. Gray iron's graphite flakes are embedded in a ferrite or pearlite matrix.
White cast iron contains 1.8% to 3.6% of carbon, 0.5% to 1.9% of silicon, and 1% to 2% manganese, while cast iron's alloys of iron, carbon, and silicon contains carbon as graphite, pure carbon as carbide in solid solution in austenite, tempered ductile iron ADI matrix austenite with 1.7 to 2.1% of carbon.
The microstructure of white cast iron contains cementite, white, and pearlite, while the microstructure of nodular cast iron contains ferrite, graphite, and pearlite. The mechanical characteristics of white cast iron is it has high compressive strength and retains good hardness and strength at higher temperature. The presence of different carbides, depending on the alloy content, makes white cast iron extremely hard and abrasion resistant but very brittle, while the mechanical characteristics for nodular cast iron is high ductility, elastic modulus, mechanical strength, and corrosion resistant. In addition, it has low cost and is easy to produce and machine. So next we move on to conclusion. In conclusion, after conducting this experiment, I found out different cast irons have different microstructure under microscope. From this, I know which cast iron is stronger. While the hardness and strength of steel almost always increase as carbon content rises, in the case of gray cast iron, the strongest, hardest grades have less carbon than some of the lower strength, less expensive grades. The graphite flakes create areas of weakness in the metal where fractures can begin that will split the metal. This propensity to fracture is why gray iron has low tensile and impact strength. Yet, the graphite flakes are what create great wear resistance because as friction occurs, the graphite acts as a lubricant. That's all for this experiment. Thank you for watching and goodbye.